Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding first and last position of an element in a sorted array. Let's look at the problem description. We are given an array of integer nums sorted in non-decreasing order, and we have to find the starting and ending position of the given target value. Okay, if the target value is not present in the array, then we have to return -1 as the starting position and -1 as the ending position. Okay, and also we are expected to write this algorithm with order of log n runtime complexity. Let's take a look at the example 1. So the nums array has 6 elements and the target value is 8. So here the 8 is present at index 3 and index 4. That's why the output is 3, 4. In the case of example 2, the target value is 6. The 6 is not present in the input array. That's why the output is -1 and -1. In the example 3, the array is empty and the target value is 0. In this case also, the starting and ending index -1 and -1. The constraints for this problem are the length of the array is ranging from 0 to 100,000 and the individual elements value is ranging from -10 to the power 9 to 10 to the power 9. And the nums array is in an ascending order, and the target value also ranging from -10 to the power 9 to 10 to the power 9. Let's look at the approach to solve this problem. So we are given the nums array which has 6 elements 5, 7, 7, 8, 8. The target value is 8 and the target value is located at index 3 and 4. That's why the output is 3, 4. The brute force approach to solve this problem is a linear search. Basically we keep track of the first index which has the target value, and then we keep traversing until we reach the end of the array, and also remember the last index that has the target value. Okay, so in this approach the time complexity is order of n, but we are expected to solve this problem with order of log n runtime complexity. Okay, to achieve that runtime complexity we can use the binary search technique. Okay, so typically in the binary search, once we locate the target value, we stop the search. But in this case, we have to continue the search until the start and end pointer cross each other. Okay, and also we have to do the binary search 2 times. Once to locate the first position of the target value, and the second binary search to compute the last position of the target value. So that's what I have written here. First we initialize the start, end and the boundary index variable, and we traverse the nums array until the start and end index cross each other. Okay, each iteration we compute the mid index and then we compare the target value with the middle element. If the target value is less than the middle element's value, then we update the end pointer with mid -1. If the target value is greater than the middle element's value, then we update the start index with mid +1. Okay, but if the target value is equal to the middle element's value, then we assign the mid index to the boundary index variable, and then instead of stopping the search we proceed. The left boundary indicates whether we are trying to find the starting position or end position. So in this case, if the left boundary is true, that means we are trying to find the start position. In this case, we always choose the left half of the subarray. Okay, so that's why we update the end pointer with mid -1. If we are trying to find the end position, in that case we always have to choose the right subarray. That's why we update the start index with mid plus 1. We repeat this until the start and ending index cross each other. Then finally we return the boundary index variable as the position of the target value. Let's look at the flowchart. Input for the find boundary index function is the nums array, target value, and then the flag left boundary, which indicates whether we are looking for the starting position or end position. If the left boundary is true, that means this procedure will try to find the start position of the target value. If this is false, this procedure will find the end position of the target value. Okay. So first we initialize the start and end indexes and then the boundary index variable. The start is initialized with index 0 and end is initialized with an index of the last element in the array. And then the boundary index is initialized with -1 because we have to return -1 if the target value is not present. Okay. Then we enter the for loop. This for loop runs until the start pointer crosses the end pointer. Okay. So each iteration we compute the mid index. Then we compare the target value with the middle element. If the target value is less than the middle element, then we update the end pointer with mid -1. Otherwise, we check whether the target value is greater than the middle element. If that is true, we update the start pointer with mid +1. Otherwise, if the target value is equal to the middle element value, then we update the boundary index variable with the mid index value. Okay. And then we check whether we are trying to find the start position of the target value or end position of the target value. If the left boundary is true, that means we try to find the start position of the target value. In that case, we have to choose the left subarray. So that's why we update the end pointer with mid -1. Otherwise, we have to choose the right subarray. That's why we update the start pointer with mid +1. And we repeat this process. Once the start pointer crosses the end pointer, then we come out and return the boundary index as the position of the target value. Let's move on to coding. First, I make a call to the find boundary index function and assign the return value to the variable first. So this call find the first position of the target value in the input array. I pass true for the left boundary flag. And again I call the same function to find the last position of the target value. In this case I pass false for the left boundary flag. Next I add the first and last variables value to the slice of int and then I return that as an output. Next I am going to write the find boundary index function, which takes the nums array and the target value and then the left boundary flag to indicate whether we are finding the first position or the last position, and then it returns an int. First I initialize the start index with value 0 and the end index with the index of the last element in the input array. Next I initialize the boundary index with value -1. Next I write the for loop. This runs until the start pointer crosses the end pointer. Each iteration I compute the mid index. Next I compare the target value with the middle element's value. If the target value is less than the middle element, then I update the end pointer with mid minus 1. If the target value is greater than the middle element, then I update the start pointer with mid plus 1. If the target value matches the middle element, then I update the boundary index variable with the value of the mid index. And then I check whether we are trying to find the starting position or ending position. If the left boundary flag is true, that means we try to find the start position. So we always have to choose the left subarray for further search. So I update end pointer with mid minus 1. Otherwise, I update the start pointer with mid plus 1 to choose the right subarray. And finally, I return the boundary index variable's value as the position of the target value. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. The input nums array has 6 elements and the target value is 8. 8 is located at index 3 and 4. That's why the expected output is 3, 4. Okay. So the search range function calls the find boundary index function 2 times. The first call is to find the start position of the target value in the input array. That's why we pass true for the left boundary flag. And in the second call, we find the last position of the target value. That's why we pass the false for the left boundary flag. Okay. And then once those two functions returned, the return value will be added to the slice and that slice will be returned as an output. In the find boundary index function, first we initialize the start, end and boundary index variables. So in this case, the start is initialized with 0 and end is initialized with the index of the last element, which is 5, and the boundary index is initialized with -1, and we passed true for the left boundary flag. Okay. Then we enter this for loop. This will run until the start pointer crosses the end. Okay. Each iteration we compute the mid index. So in this case, in the iteration 0, the start index is 0, end is 5, and the mid index value will be 2. Okay. Next, we compare the middle element's value with the target value. Okay. If the target value is less than the middle element, then we update the end pointer. Otherwise, if the target is greater than the middle element, then we update the start pointer. So in this case, the target value is greater than the middle element. Okay. So we update the start pointer with mid plus 1. So that's why the start is updated to 3. It is changed from 0 to 3. Okay. And in the iteration 1, the start index is 3 and end index is 5. So when we compute the mid index, it is 4. Okay. Then we compare the middle element's value with the target value. Now target value is equal to the middle element's value, so we update the boundary index variable with the mid index. So that's why the boundary index is changed from -1 to 4. Okay. Next we check whether we are trying to search the first position or the last position. So in this case we try to find the first position, so we update the end pointer with mid -1. Okay. So the end pointer is changed from 5 to 3. Okay. And then we proceed the search to check whether is there any other elements has a value 8. So in the iteration 2, the start and end indexes value is 3, and when we compute the mid index value, that is also 3. Okay, so when we compare the target value with this value, both the values are equal. So we update the boundary index variable with the mid index value. That's why it is changed from 4 to 3. Okay, so once that is done, then we update the end pointer with mid minus 1. So the end pointer changed from 3 to 2. Okay, so in the next iteration, start is greater than end, so we break out of this loop, and then we return 3 as the start position of the target value, and that's assigned to variable first. Okay, next we try to find the last position of the target value. That's why we pass the flag false to the left boundary flag. Okay, so in the iteration 0, the start index is 0 and end index is 5, mid index value is 2. Okay, then we compare the target value with the middle element. So in this case, the target value is greater than the middle element, so we update the start pointer with mid plus 1. So that's why it's changed from 0 to 3. Okay, and in the iteration 1, again we compute the mid index. So in this case, the mid index value is 4. Okay, next we compare the value of the middle element with the target variable. So in this case it is equal, so we go ahead and update the boundary index with the mid index value. So the value of the boundary index is changed from -1 to 4. Okay, after updating the boundary index, then we update the start index with value mid plus 1. Okay, so in this case, the start index value is changed from 3 to 5. Okay, so in the next iteration, the start and end indexes are pointing to the same element at index 5, and then when we compute the mid index, that is also 5. Then we compare the value of the middle element with the target value. In this case, this value is greater than the target value, so we update the end pointer with mid minus 1. Okay, so that's why the end pointer is changed from 5 to 4. In the next iteration, the start index is greater than the end index, so we break out of this loop, and the boundary index has value 4, which is the last position of the target value 8. Okay, then that value will be assigned to the variable last. Then we add first and last variable value to the slice and return that as an output. In this case, it is 3, 4. That is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of log n. Okay, let's take a look at the case where the nums array has 6 elements. Okay, the search range function make a call to the find boundary index functions 2 times. Okay, so this function in turn perform a binary search on the nums array. Okay, so basically this for loop performs 3 iterations, which is equal to log 6 plus 1. So if there are n elements, this for loop performs log n plus 1. Because we are calling this function 2 times, so the total runtime will be 2 times log n plus 1. Okay, so after removing the constant factors out, we get order of log n as the runtime complexity. Okay, the space complexity is order of 1 because we are not allocating any additional space in terms of the input size, but we make a call to this function, so regardless of the input size, we call this function 2 times. That stack space is also constant regardless of the input size. Okay, and also we do not allocate any additional space, so that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.